Picture this. You walk into your living room and say, "Movie time," and instantly your lights dim to the perfect level, the shades glide down, and your TV powers on, all without lifting a finger. That's not some futuristic fantasy anymore. That's what custom voice commands can do for your smart home right now. I'm Marcus Chen, and I've spent years helping people turn their homes from a bunch of individually controlled gadgets into systems that actually think ahead and respond to how they live. You're listening to the Smart Home Setup Podcast. Quick note before we get going, everything you're hearing is researched and written by real people who actually install and test this stuff, but the voice you're listening to right now is AI generated. The data, the script, the expertise, all human. The narration, not so much. Just wanted to be upfront about that. If you've been listening to the show for a while, thank you. Seriously. I know your time is valuable, and I'm glad you're here. If you're new to the podcast, welcome. We release new episodes every Monday, Wednesday, and Friday covering smart home tech, automation, protocols, troubleshooting, all of it. Today, we're talking about custom voice commands and how to actually set them up so they work reliably. Let's get into it.
You've probably said "turn on the lights" to your voice assistant hundreds of times, but learning how to create custom voice commands transforms your smart home from a collection of individually controlled devices into a cohesive system that responds to your exact routines. In this guide, you'll learn how to build custom voice commands across Amazon Alexa, Google Assistant, and Apple HomeKit, with specific instructions for each platform's automation logic, protocol requirements, and realistic latency expectations. This is beginner to intermediate level stuff. You're looking at about 30 to 60 minutes per custom command, longer if you're sequencing multiple devices. You'll need at least one voice assistant device and compatible smart home devices already set up before we get started. Now, let's talk about what you'll need before you start creating custom voice commands. First, you need a voice assistant device. That's an Amazon Echo of any generation, a Google Nest or home speaker, or an Apple HomePod or HomePod Mini. You also need compatible smart home devices that are already installed and functioning through your chosen ecosystem. You'll need your smartphone or tablet with the corresponding app installed. That's the Alexa app, Google Home app, or Apple Home app. Make sure you've got a stable home network, either 2.4 GHz or 5 GHz Wi-Fi, with consistent coverage where your voice assistant is located. For hub compatibility, if you're using Zigbee devices, confirm your hub is connected. For Z-Wave devices, ensure your controller is paired with your voice assistant ecosystem. All devices and apps should be running current versions. Check the manufacturer apps to update firmware. And here's something a lot of people overlook. You need to know which protocol each device uses. You'll need this information for troubleshooting latency issues later. In my experience, the most common failure setup happens when homeowners assume all their smart devices are compatible with custom commands. Not all devices support advanced automation, particularly older Wi-Fi bulbs and budget plugs that only respond to basic on and off commands. Moving on to step 1, map your devices and verify protocol compatibility. Before writing any automation logic, you need to know exactly which devices can communicate with each other and how quickly they'll respond. Open your voice assistant app and create an inventory list. For each device, note the device name exactly as it appears in the app, the protocol type, that's Wi-Fi, Zigbee, Z-Wave, Thread, or Matter, whether it's standalone or requires a bridge or hub, the current firmware version, and the room assignment. This step matters because latency stacks. If you're creating a good morning command that controls 8 devices and each device takes 2 seconds to respond, you're looking at 8 to 16 seconds of total execution time. That's frustratingly slow.
Here's what to expect from each protocol when triggering commands. Wi-Fi devices typically have a 1 to 3 second response time, and that depends on router load and whether the device relies on cloud connectivity. Zigbee devices respond in about half a second to 1 second because they use local mesh communication, which is faster than Wi-Fi. Z-Wave devices also respond in about half a second to 1 second, similar to Zigbee, but they tend to be slightly more reliable when you have many devices on the network. Thread and Matter devices are the fastest in 2026, responding in about 0.3 to 0.8 seconds for local control. For a deeper explanation of how these protocols differ, check out our Smart Home Protocols Explained guide. You'll find the link in the show notes. Here's a pro tip from installation experience. Group devices by protocol when possible. If you're creating a bedtime command, having all your bedroom lights on the same Zigbee mesh means they'll execute nearly simultaneously, rather than staggering across different network types. Step 2 is where we design your automation logic using if-then statements. Now that you know your device capabilities, write out your custom command logic before touching the app. This prevents the frustration of discovering mid-setup that your intended sequence won't work. Use this format. If the trigger phrase is spoken, then Action 1 happens, and Action 2 and Action 3. You can add optional timing with delays, and you can define what happens if a device fails. That's your fallback. Here's your real-world example I helped a client build. If Alexa, activate dinner mode is spoken, then the dining room chandelier goes to 75% brightness, that's a Zigbee device on a Philips Hue bridge, and the kitchen pendant lights go to 60% brightness, also Zigbee on the same bridge. The living room floor lamp turns off, that's a Z-Wave device on a SmartThings hub. Background music starts playing a Spotify dinner playlist at 40% volume, that's a Wi-Fi connection through the Echo device. There's a 2-second delay between the light changes and when the music starts, and if any light fails, the sequence continues anyway. Notice the protocol mix? The Zigbee lights execute almost instantly through the Philips Hue bridge, while the Z-Wave lamp routes through SmartThings. The total execution time is roughly 3 to 4 seconds, which is acceptable for most users. Write out 3 scenarios you want to automate. Keep them simple at first. Bedtime, good morning, and leaving home are classics that teach you the fundamentals before you attempt complex conditional logic. Let's get into step 3. Creating custom commands in Amazon Alexa using routines.
Amazon calls custom voice commands routines, and they're one of Alexa's most powerful features. Here's exactly how to create them step by step. Open the Alexa app and tap More at the bottom right, then Routines, then the plus icon at the top right. Set your trigger by tapping When This Happens, then Voice. Type your exact custom phrase. This is what you'll say to activate the routine. Don't use Alexa at the start. The system adds that automatically. So if you want to say, Alexa, good morning, just type Good morning. Now add your actions. Tap Add Action. You'll see categories like Smart Home, Music, News, Traffic, Weather, Alexa Says, Wait, and more. For each device in your sequence, tap Smart Home, then Control Device. Select the specific device, choose the action like on, off, brightness, temperature, and if applicable, set specific values like 75% brightness or 68 degrees Fahrenheit. Here's an important timing consideration. By default, Alexa executes actions in sequence with about 1 second between each. If you need precise timing, like waiting 30 seconds before turning off a bathroom fan, add a wait action between device commands. Now, about fallback behavior. Alexa routines don't have explicit fallback logic. If a device is offline or unresponsive, Alexa will announce, "Device X is not responding," and continue to the next action. I've seen this frustrate homeowners who expect the entire routine to fail gracefully. You can't override this behavior without third-party platforms like Home Assistant. Here's where protocol knowledge becomes critical. If you're controlling a Zigbee bulb through a Hue bridge, that bulb must be responding to the bridge. If the bridge is offline, Alexa can't reach it. The same applies to Z-Wave devices through hubs like SmartThings or Habitat. For multi-protocol homes struggling with device coordination, our guide on how to plan your smart home automation system covers hub requirements and network architecture. Links in the show notes. After saving your routine, test it immediately. Say your custom phrase and watch the execution. Time it with your phone's stopwatch. If any device lags beyond 3 to 4 seconds, check its protocol connection and hub status. Step 4. Create custom commands in Google Assistant using routines.
Google Assistant also calls these routines, but the interface and capabilities differ slightly from Alexa. Here's how to create custom voice commands in the Google ecosystem. Open the Google Home app, tap Automations at the bottom menu, then the plus icon at the top right, then Household Routine. Set your starter phrase under Starters. Tap Add Starter, then Voice Command. Type your exact phrase. Unlike Alexa, you do not need to include Hey Google or OK Google in the text. The system assumes that prefix.
Google allows multiple trigger phrases for the same routine. If you want good morning, wake up, and start my day to trigger the same sequence, add all three here. This flexibility is something Alexa lacks. Add your actions by tapping Add Action. Google groups actions into categories like adjust home devices, adjust volume and media settings, adjust lights, plugs, and switches, or try adding your own custom actions. Select Adjust Home Devices for smart home control. Choose each device and its specific action: on, off, brightness level, color temperature, and so on. About sequencing and delays. Google routines execute actions in the order listed, but unlike Alexa, you can't insert precise wait times between actions. The delay is roughly 1 second between each action, and you can't customize it without third-party integration. Here's a conditional logic limitation. Google Assistant doesn't support if device X is already on, skip this action logic natively. Every action in your routine will execute regardless of device state. This can create awkward scenarios, like dimming lights that are already off. Protocol compatibility is worth noting here. Google Assistant works seamlessly with Wi-Fi, Matter, Thread, Zigbee through compatible hubs like SmartThings, and some Z-Wave devices that are also hub-dependent. However, Google's local control for Zigbee and Z-Wave is less reliable than Alexa's in my testing. Expect slightly longer latencies when commanding hub-connected devices. For specific comparisons between Google and Alexa ecosystems, see our article titled Alexa versus Google Assistant for Smart Home Control, Which is Better? Links in the show notes. Test your routine by speaking your custom phrase and timing the execution. Google routines tend to be slightly faster for pure Wi-Fi devices, but slower for multi-hub setups compared to Alexa. Step 5. Create custom commands in Apple HomeKit using shortcuts and scenes. Apple's approach to custom voice commands splits into two methods. Scenes are for simultaneous device control, and shortcuts are for sequential automation with conditional logic. Both work with Siri as the trigger. For simple simultaneous control using scenes, open the Apple Home app, tap the plus icon at the top right, then Add Scene. Name your scene. This becomes your voice command like movie time or bedtime. Tap Add Accessories and select every device you want to control. Set each device's specific state, on, off, brightness, temperature, then tap Done. Now say Hey Siri followed by your scene name to activate everything at once. All compatible devices execute within 1 to 2 seconds. This is the fastest method for HomeKit commands because it's pure local control if you're using a HomePod or Apple TV as your home hub.
For sequential or conditional automation using shortcuts, open the Shortcuts app, not the Home app, tap the plus icon at the top right, then Add Action. Search for Set Scene or Control Home. You can build complex logic here. For example, if the condition is bathroom light on, then turn off the bathroom light, else do nothing. Or you can create sequential delays. Set living room lights to 80%, wait 5 seconds, set TV to on, wait 2 seconds, set soundbar volume to 30%. HomeKit shortcuts allow genuine if-then conditional testing, something Alexa and Google struggle with. However, the interface is significantly more complex, and non-technical users often abandon it for simpler scenes. About protocol support, HomeKit is the most restrictive ecosystem. As of 2026, HomeKit officially supports Wi-Fi devices with HomeKit certification, Thread devices with native support through HomePod Mini and Apple TV 4K,
Matter devices with full support starting with Matter 1.0, and Zigbee and Z-Wave devices only through certified third-party hubs like the Aqara Hub M2 or Hubitat with HomeKit integration. If you have Z-Wave devices and want HomeKit control, you'll need a bridge hub. This adds latency, typically 1 to 2 extra seconds, and another potential failure point. For detailed protocol compatibility guidance, read our article Voice Assistant Smart Home Protocol Compatibility Explained. That link's in the show notes. Test by speaking your custom phrase and observing execution. HomeKit's local processing makes it the fastest ecosystem when all devices are Thread or Wi-Fi native, but hub-dependent devices lag noticeably. Now we're at Step 6. Test latency and reliability across scenarios. Creating a custom voice command is only half the battle. You need to verify it works reliably under different network conditions and device states. Run these 5 tests for every custom command you create. Test 1 is fresh execution. Speak your command when all devices are idle and responsive. Time the full sequence from voice recognition to final device action. This is your baseline. Test 2 is busy network. Stream 4K video on your TV while executing the command. Does latency increase? Wi-Fi devices will suffer most. Zigbee and Z-Wave should remain unaffected since they use separate mesh networks. Test 3 is device already in target state. If your movie time command turns off kitchen lights, test it when those lights are already off. Does the routine stumble or does it gracefully continue? Test 4 is hub offline. Unplug your Zigbee or Z-Wave hub and try the command. What happens to hub-dependent devices? Spoiler, they fail silently in most ecosystems. Test 5 is Voice Assistant offline. Disconnect your Echo, Google Home, or Apple Pod from Wi-Fi and try the command. Some Thread and Matter devices can execute automations locally through border routers, but most setups fail completely without cloud connectivity.
Record your results. If any test shows latency exceeding 6 to 7 seconds total, your users will perceive the automation as broken, even if it technically works. In my installations, anything over 5 seconds gets complaints. Here are some common failure patterns I've diagnosed. Z-Wave devices timing out is usually caused by weak mesh signal or hub overload. Solution: add Z-Wave repeater devices. Smart plugs work great for this. Wi-Fi bulbs dropping commands is typically router congestion. Solution: move bulbs to a 2.4 GHz only guest network or upgrade to Zigbee. Google routines skipping actions often means device names with special characters confuse the parser. Solution: rename devices to alphanumeric only names. HomeKit scenes not triggering usually means your home hub, the HomePod or Apple TV, is in standby mode. Solution: keep the home hub powered and connected 24/7. For specific guidance on testing device response times, see our article, How to Test Smart Device Response Times and Latency Across Protocols. Links in the show notes. Moving to Step 7, build conditional logic and fallback behaviors. Basic custom commands work fine until real life interrupts them. Someone manually turns on a light, your toddler unplugs a smart plug, or a firmware update bricks a device at midnight. Advanced custom voice commands anticipate these failures. Amazon Alexa has conditional options, but they're limited. Alexa supports some conditionals through wait actions and featured category automations, like only run between sunrise and sunset. For true if-then logic, you need to integrate Alexa with third-party platforms. Here's an example workaround. Create 2 separate routines, Movie Time Daytime and Movie Time Evening, with different device actions. Use Alexa's schedule feature to enable or disable each based on time of day. It's not elegant, but it's functional. Google Assistant conditional options are even less limited. Google routines execute linearly without state checking. To achieve something like turn on lights only if they're currently off, you need Google Home integrated with Home Assistant or another home automation platform. HomeKit conditional options are where HomeKit shortcuts shine.
You can build genuine conditional triggers. For example, if the kitchen motion sensor detects movement and the time is between 6 a.m. and 8 a.m. and the kitchen lights are off, then turn on kitchen lights to 40% and start the coffee maker. Else, do nothing. The trade-off? Complexity. HomeKit shortcuts require significantly more setup time than Alexa or Google routines.
About fallback behaviors. None of the major ecosystems handle device failures gracefully without third-party integration. Here's what actually happens. Alexa announces, "Device X is not responding," and continues to the next action. Google silently skips the failed device and continues the sequence. HomeKit displays a notification on your iPhone or iPad and continues the sequence. If you need robust fallback logic, like if bedroom light fails, turn on hallway light instead, you'll need Home Assistant, Habitat, or another advanced platform. For most homeowners, the native fallback behavior of continuing despite failures works acceptably. For power outage scenarios specifically, read our guide, How to Configure Smart Home Fallback Automations During Power Outages. That link's in the show notes. Let's talk about Step 8. Optimize voice recognition and reduce false triggers. You've built your custom command, but now your voice assistant keeps misinterpreting it or triggering at random. This happens constantly with vague or common phrases. Choose distinct trigger phrases. Avoid single words or phrases that appear in normal conversation. Lights triggers accidentally when someone says, "I love these lights in here." Instead, use phrases like activate evening mode, not just evening. Good morning routine, not just good morning. Start movie time, not just movie. Test voice recognition accuracy. Speak your custom phrase from different locations in the room, near the voice assistant, across the room, from an adjacent room. If accuracy drops below 90%, rephrase the trigger. Adjust voice assistant sensitivity. For Alexa, open the Alexa app, go to Devices, then Echo and Alexa, then select your device, then wake word. You can't adjust sensitivity, but you can choose different wake words like Alexa, Amazon, Echo, or computer. For Google, open the Google Home app, go to Settings, then Google Assistant, then Your People, then Add People. In HomeKit, open the Home app, go to Home Settings, then People, then Invite People. This prevents delivery drivers or visitors from accidentally or maliciously triggering sensitive commands.
For a comprehensive setup process covering voice recognition and custom commands together, see our guide, How to Set Up Voice Control for Your Smart Home. Links in the show notes. Now, some pro tips and common mistakes. After configuring custom voice commands across hundreds of installations, I've noticed these patterns repeatedly. Mistake number 1, creating commands that control too many devices at once. I watched a client build a bedtime routine controlling 23 devices, every light, lock, thermostat, and fan in their home. Total execution time was over 30 seconds, and if any single device failed, they'd lose confidence in the entire system. Keep custom commands to 5 to 8 devices maximum. Build multiple smaller commands instead of one massive routine. Mistake number 2, forgetting about voice command conflicts. If you have an Alexa routine called Lights On and a Hue scene also called Lights On, Alexa gets confused about which to trigger. Rename one to avoid conflicts. Mistake number 3, not accounting for hub dependencies. A homeowner told me their Good Morning command worked perfectly for 6 months, then suddenly stopped controlling half their devices. The issue? Their Philips Hue bridge needed a firmware update, which paused Zigbee communication until it completed. Always document which devices depend on which hubs. When troubleshooting, check the hub first. Pro tip, Use status announcements strategically. Alexa and Google can announce, "Good morning, starting your day," when you trigger a command. This verbal confirmation helps you know the routine started even before you see lights change. But don't add announcements to frequently used commands. Hearing "movie time activated every evening" gets annoying fast. Another pro tip, test commands at different times of day. That "good morning" command that works perfectly at 7 a.m. might trigger differently at 7 p.m. if you have time-based conditional logic or smart devices that respond differently based on ambient light sensors. Mistake number 4, not leveraging Matter devices for reliability. If you're building a smart home in 2026 and still buying Wi-Fi only devices, you're choosing the highest latency, most cloud-dependent option. Thread and Matter devices cost roughly the same now, but respond dramatically faster. For a current overview, see our article Matter 1.4 Smart Home Protocol, Complete Guide to Cross-Platform Automation. That's in the show notes. Frequently asked questions.
Can I create custom voice commands that work with multiple voice assistants simultaneously? Yes, but you'll need to create separate routines in each ecosystem. A Matter-compatible device can be controlled by Alexa, Google, and HomeKit simultaneously, but you must build the Good Morning routine separately in the Alexa app, Google Home app, and Apple Shortcuts app. Each will trigger with that ecosystem's wake word only. There's no cross-platform custom command that responds to "Hey Google" and "Alexa" from the same trigger phrase, even with Matter devices. Do custom voice commands work offline if my internet goes down? It depends on your devices and ecosystem. HomeKit with Thread or locally controlled Zigbee devices can execute scenes offline as long as your home hub, the HomePod or Apple TV, remains powered. Alexa and Google routines require internet connectivity for voice recognition and routine processing. Without internet, the voice assistant won't understand your command at all. Z-Wave and Zigbee devices can continue operating through hubs that have local processing, but you lose voice trigger capability. Can I use custom voice commands to control devices on different protocols like Zigbee and Z-Wave in the same routine? Absolutely, and it's common in multi-protocol homes. Your voice assistant sends commands through whatever bridge or hub each device requires. A Zigbee light receives commands through your Hue bridge, a Z-Wave door lock through your SmartThings hub, and a Wi-Fi plug directly. The execution happens sequentially in the order you arranged them, which means slight latency differences between protocols. Expect Zigbee and Z-Wave devices to respond in under 1 second, Wi-Fi devices in 1 to 3 seconds. Why does my custom voice command sometimes skip devices or execute out of order? This usually indicates network congestion, hub overload, or weak mesh connections. If your routine commands 8 devices through a Zigbee mesh, but several devices are at the edge of signal range, they'll receive the command slower or miss it entirely. For Wi-Fi devices, heavy bandwidth usage like streaming or video calls during command execution causes delays. Check your hub's activity logs to identify which devices are timing out. Then either strengthen mesh networks by adding repeater devices or reduce the number of devices in that specific command. So here's the summary. Learning how to create custom voice commands elevates your smart home from basic voice control to truly automated experiences tailored to your routines. The process varies significantly across Alexa, Google Assistant, and HomeKit. Each ecosystem offers different conditional logic capabilities, latency characteristics, and protocol support. Start with simple 3 to 5 device commands that combine devices on the same protocol for faster execution. Then expand to more complex sequences as you understand your network's reliability patterns. Test every custom command under different network conditions and document which devices depend on which hubs so troubleshooting failures become straightforward. And remember, if a command takes longer than 5 to 6 seconds to fully execute, your household will perceive it as broken regardless of technical success. Keep commands focused, test them thoroughly, and don't hesitate to split one large routine into multiple smaller ones for better reliability. That wraps up today's episode of the Smart Home Setup Podcast. Thanks for listening all the way through. We'll be back with a new episode on Monday, Wednesday, and Friday, so there's always something new coming your way. If you found this episode helpful, I'd really appreciate it if you left a 5-star rating and maybe a quick review. It honestly makes a huge difference. It's how other people who are searching for smart home advice actually find the show. And if you haven't already, hit subscribe or follow so you get notified the second a new episode goes live. I'll see you in the next one.